Hi students, welcome to the part 3 PYQ discussions of the chapter functions. So, in this video, we will be discussing some important questions from 2024 and 2025. Okay, and along with that, some important concepts and shortcuts will be discussed. So, stay tuned till the last question as this video will be very important and useful for the upcoming examination. Okay, so let's start. Our very first question from 2025. Okay, two sets are given, A and B. Okay, then we need to find the number of many one functions from A to B such that one is always element of f of A. So, how are you going to formulate this one? It's an easy question actually. See, two sets are given, right? A and B. Okay, we need to formulate the number of many one functions from A to B. Okay, that is easy. But the thing here is, for that many one functions, one should always be in the range. Okay, the element 1 should always be in the range. So, how are you going to do this question? See, let's start from finding the number of many one functions that is possible from A to B without this condition. Okay, let's do it like that. So, what is the number of functions that is possible from A to B? See, if set A has m elements and set B has n elements, then what is the number of functions that is possible from A to B? You know that? That is n raised to what? M. The number of functions that is possible from A to B is what? N raised to m. Okay. So, what is the number of functions that is possible from A to B here? That is 4 raised to 4. Total number of function is what? 4 raised to 4. That is equal to 256. Okay. So, what is the number of 1 functions that can be possible from A to B? That's another formula. See, again, consider two sets A and B. A is number of elements in A is m and number of elements in B is what? N. Okay. The condition is like n should be what? Greater than or equal to m. Only then 1 functions are possible. Okay. Otherwise, it won't be a 1 function. Okay. Number of 1 functions will be 0. If n is less than m, then the number of 1 functions will be 0. Okay. So, if it is the case, then what is the number of 1 functions that is possible from A to B? It's easy actually, that is n p m. Okay, that is the number of 1 functions that is possible from A to B. Hope you got the idea here. So, what is the number of 1 functions that is possible from A to B? That is 4p4, that is 4 factorial, that is what? 24. Okay, hope you got it. So, these are the total number of functions and this is the total number of 1 functions. Okay, so what is the total number of many one functions? I hope you know the property, right? A function is either 1 or many one. Okay, so out of 256, only 24 is 1 functions. Okay, so remaining will be what? Many one functions. So number of many one functions will be this minus this, that is 232. Okay, so if you write those 232 1 functions here like this, one after the other, some of them will have element 1 in it as the range. Okay, in the range, the function will have element 1 in it. Okay, we need to find the number of those functions. How are you going to formulate this? I think it's better to find this one using the complement technique. Okay, so this much many one functions are there. Now we are going to find the number of many one functions where 1 is not an element of f of A. Okay, therefore, number of many one functions where 1 is not an element of f of A. So, it will be like 1, 2, 3, 4 here and 4, 9, 16 here. Okay, so how many one functions are possible? See, number of many one functions from here to here will be same as number of functions, right? See, this number of elements in this is greater than number of elements in this. Okay, so all the functions which is defined from this set will be what? Many one functions. Okay, so how many many one functions are there? It's easy, which will be equal to number of functions. So how many functions are here? That is 3 raised to 4. That is what? 81 functions are possible and all of those 81 functions will be what? Many one functions. Okay, so number of many one functions is equal to what? 232 and number of many one functions where 1 is not element, okay, in the range is what? 81. So, number of many one functions where 1 is an element of f of A is what? 232 minus 81. Okay, that is 151. Okay, hope you got the idea here. a very good question. To do this question, we need to know the formulas of this one and like that. Okay, number of functions which can be formulated. You need to have a good idea about one and many one functions. The condition for one and many one functions like that. Okay, so hope you got the idea here. So the next one. Okay, a question which is very much like this. So one more thing, that was the last question from 2025. Okay, we have discussed every other questions. Okay, in the last two sessions. So next question from 5th April 2024, shift 1. Again, two sets are given, A and B, and the total number of 1 maps from A to B such that f of 1 plus f of 3 is equal to 14. How are you going to do that? There is a condition also, the number of 1 functions from A to B such that f of 1 plus f of 3 is equal to what? 14. So how are you going to do this one? Easy actually. See, this set has how many elements in it? 5 elements in it. Okay, this has 3, 6, 7 elements in it. So without this condition, okay, which if we neglect those condition, how many 1 functions will be there? 7p5. Okay, if the condition is not like that, so how many 1 functions will be the 7p5? Okay, and we can formulate this. Okay, I think it's easy with respect to the last question. Okay, therefore I am mapping this like expressing it like f of 1, f of 3, f of 5. Sorry, f of 7, f of 7, f of 9, f of 11. Okay. There is only one condition such that f of 1 plus f of 3 is equal to what? 14. So, okay, the elements in the codomain are like 2, 4, 5, okay, 7, 8, 10, 12. So, which are the values that can be assigned to f of 1 and f of 3 here? That 2 and 12 can be assigned, right? Therefore, here it is 2, sorry, here it is 2 and here it will be what? 12. Okay, so we already took 2 elements from here and how many elements are left? 5 elements. Those 5 elements can be distributed here. Okay, so the thing is, if we take, we already considered 2 and 12, right? 2 and 12. Okay, so if we include those 2 and 12 here and here as well, then the function becomes what? Many one. Okay, so we need to include those 2 elements. So how many elements will be the 5 elements here? How many elements, how many functions are here? How many functions which we need to map here? 3. So this 5 can be arranged in this 3 in how many ways? 5p3 ways. So total how many ways? 5p3 ways. With respect to this one, is it correct or not? It's not correct. There is a slight modification here. See, f of 1 is 12 and f of 3 is 12. F of 1 is 2 and f of 3 is what? 12. Is there any other possibility other than this? There is one more actually. That is f of 1 can be 12 and f of 3 can be what? 12. Okay. Then also the sum will be equal to what? 14, right? See, then also it will be what? 5p3. So basically it is 5p3 into what? 2 factorial. Okay, so that's done. Okay, this is done. The next set. Which are the next set that is possible such that f of 1 plus f of 3 is equal to 14? Any other thing? Yes, 4 and what? 10. Therefore 4 here and 10 here. Okay, therefore 4 plus 10 is what? 14. One more possibility, that is 10 and 4. That is 2 factorial here. How many will be left here? 5. Okay, that is 5p3. So what is 5p3? 5 factorial divided by 2 factorial, that is 120 by 2, that is 60. 60 into 2 factorial is what? 120. Here also it will be same 120. So 120 plus 120 is what? 240. So 240 is the final cut answer for this one. Okay. Hope you got the idea here. The next question was the easy one. Okay. Okay. Let the sum of maximum and minimum values of the function f of x is equal to 2x square minus 3x plus 8 divided by 2x square plus 3x plus 8 be m by n. Okay. Where greatest common divisor of m and n is 1, then you need to find the value of m plus n. How are you going to find this one? There is 2 methods which we can use here. The first method is like the basic method. Okay, that is putting y is equal to like that and equating it and finding the range, and from the range we can operate the maximum value and minimum value like that. And the next method is go for increasing and decreasing, that is finding maximum and minima after differentiation. Okay, I think it's better to differentiate here. Okay, so before differentiation we need to formulate the numerator. Okay, so make the things more easier. Okay, during differentiation. So what I'm going to do here is we have discussed the simplification of these types of expressing this type of expression in a more compact way so that we can differentiate it more easily in the last two sessions. Okay, so let's start from here. Okay, so let's make this a more easier one at first. Therefore, it will be f of x is equal to, see, the numerator can be expressed like this, 2x square plus 3x plus 8 minus 6x. That is, actually it is 2x square minus 3x plus 8 divided by the denominator. See, this and denominator will be same. Therefore, this by denominator is 1 minus 6x divided by 2x square plus 3x plus 8. This can be represented like this. Okay, so we need to, our objective is to differentiate this by expressing this from this. The differentiation becomes more easier. Okay, so f dash of x. So what is f dash of x? This is 0 and minus 6 into quotient rule. Okay, differentiating here and here becomes quotient rule. That is, it will be 2x square plus 3x plus 8 into 1, right? Minus x into, that is 4x plus 3, okay, divide by the denominator square, which we can perform later. Okay, that is f of x is equal to minus 6 into, how will you formulate this one? 2x square minus 4x square, that is minus 2x square. Okay, and 3x minus 3x got cancelled, and plus 8. Okay, divide by denominator square. Okay, hope you are getting the idea here. So next thing is, I am taking negative 2 from here. Therefore, this becomes f of x is equal to 12 into, inside it will be x square minus 4. If you take minus 2 from here, it will be x square minus 4. That can be written as x plus 2 into what? X minus 2 divided by denominator square. Okay, so let's do one thing. Move to the next slide. It will be 12 into, that is f of x is equal to 12 into x plus 2 into x minus 2 divided by 2x square plus 3x plus 8 the whole square. 2x square plus 3x plus 8 the whole square. Okay, so before proceeding further, we can formulate the denominator first. So what is the discriminant of the denominator? The discriminant of the denominator will be, is it greater than 0 or less than 0? That is, discriminant will be 9 minus 4 into 2 into 8, b square minus 4ac. Therefore, the discriminant of the denominator is what? Less than 0. So, the denominator part will never be equal to what? 0. Okay, therefore, we don't have to bother about this one, and that they will, the denominator, even if we are not squaring it also, it will be positive, because if the discriminant is 0, the sign of this quadratic expression will entirely depend on the sign of the coefficient of x square, that is positive here. Okay, therefore, even though we are squaring it here, the denominator will be what? Positive here. Therefore, we need to bother only about what? The numerator. The numerator, I think we can operate it like this, that is 2 and minus 2 here. Okay, minus 2 and 2 here, sorry. Okay, tell me a number which is greater than 2, that is 4. In 4 it will be positive, so here it will be negative, here it will be what? Positive. So, according to maxima minima condition, which point is maxima and which point is minima? The graph will be like this, right? I am writing it here, it will be like this here, and it will be like this here. Okay, so this is maxima and this is what? Minima. So, maxima occurs at what? Maxima minima occurs at x is equal to what? Minus 2, and minima occurs at x is equal to what? 2. That's all. Just substitute the values and add them. Okay, that is, what is f of minus 2? F of minus 2, sorry. What is f of minus 2? That is, the denominator was same, right? We can operate it first, that is 2 into minus 2 whole square. What is 2 into minus 2 whole square? 4 and 8. 8 plus 8 is what? 16. 16 minus 6 is what? 10. Okay. And f of x is equal to 2x square minus 3x plus 8 divided by f of x is equal to 2x square minus 3x plus 8 divided by 2x square plus 3x plus 8. This value we have already formulated here, and this one, this will be 8 plus 8 is 16 minus 2, right? 8 plus 8 16, 16 plus 6 is what? 22. Okay. And what is f of minus 2? F of 2. This is f of 2. Okay, this is f of minus 2. Now we are going to find f of 2. What is f of 2? If you substitute it here, you will get 4 plus 4, 16. That is 10 divided by, this will be what? 22. The reciprocal of that will be obtained. Therefore, it will be 11 by 5 plus what? 5 by 11. That is 125 plus 25. What is 125 plus 25? 121 plus 25, 121, 25, that is 146. 146 divided by what? 55. That is equal to m by n. That is the maximum and minimum values. I think there is no common factor among them. Okay, therefore we need to add it. You need to find the value of m plus n, right? So what is the value of m plus n? That is 201. Okay, so the value of m plus n is what? 201. Okay, hope you got the idea here. Was an easy and doable question. Also time saving question. Okay, and the next one. Okay, a slightly interesting question. A function defined from real numbers to real numbers, domain and codomain are real numbers, given by f of x is equal to x square plus 2x minus 15 divided by x square minus 4x plus 9. Okay, and we need to identify the function. Okay, whether it's 1, 1 or many 1, on 2 or into, like that. How are you going to do this one? I think it's better to use the conventional method here. Okay, so normally if in your board examination, most students are going to appear for now, how are you going to formulate this one? See, you will substitute x1, you will formulate like f of x1 is equal to f of x2, and you will equate, and at last whichever value you are getting, that is if you are getting x1 is equal to x2 only, then the function is what? 1, 1. Otherwise, if you are getting any other results other than x1 is equal to x2, then the function is what? Many 1. Okay, that's how you are going to do that. I think here there is another shortcut for doing this question. I will tell you. See, can you factorize x square plus 2x minus 15? That is, f of x is equal to, what is x square plus 2x minus 15? That is x plus 5 into what? X minus 3 divided by this. I think we cannot formulate it. Okay, that is x square minus 4x plus 9. So what is the discriminant of the denominator? It is negative, right? Okay, you can formulate that. Discriminant is what? Less than 0. If discriminant is less than 0, then the quadratic expression cannot be 0. Okay, this value will also always be what? Positive, since the sign of x square is positive. So we have already formulated what is the answer here? Is it 1, 1 or many 1? For that we have already formulated here. What is the answer? Is it 1, 1 or many 1? Actually, it is many 1. Why? Because what is the value of f of 3? Substitute f of 3 here. What will you get? 0 by this, that is 0. And what is the value of f of minus 5? Both of them are getting the same answer as what? 0. Is it possible if a function is 1, 1? No, it's not possible. Okay. See, therefore, which function is this? It's a many 1 function. We have already formulated that. Now, we need to obtain whether the function is, we need to identify whether the function is onto or into. So, how are you going to formulate that? Easy. Let's put y is equal to the conventional method of finding the range, very conventional method. Y is equal to x square plus 2x minus 15 divided by x square minus 4x plus 9. Okay. So, using our conventional method, what I am going to do is, I am cross multiplying this, I am taking this to the left hand side at the same time. So, this will be x square y, okay, minus x square minus 4xy minus 2x plus 9y minus 15 is equal to 0. Okay. So, it will be x square into y minus 1 minus 2 into minus 2x into, this will be 2y plus 1 plus 9y, okay, this is plus 15, okay, 9y plus 15 is equal to 0. So, this is a quadratic equation in x. So, what can you formulate from this? It's easy actually. See, they have already mentioned that x is element of real numbers. So, let's start with the quadratic equation here. Let's take a quadratic equation, ax square plus bx plus c is equal to 0. See, if the discriminant of this quadratic equation is greater than or equal to 0, then what can you obtain from that? That is, its root will be real. Okay. So its root will be real. That is, if the discriminant is greater than or equal to 0, the roots of the corresponding quadratic equation is real. So if it is stated in the reverse order, that is, if the roots are real, then what can you conclude from that? The discriminant will be greater than or equal to 0. Okay, hope you got the idea here. Therefore, we already know the roots of this quadratic equation is what? Real. Therefore, its discriminant should be what? Greater than or equal to 0. That we can operate in the next slide. Okay, therefore, it will be, the square of this will be, that is 4 into, okay, 2y plus 1 the whole square. That is 4 into 2y plus 1 the whole square minus 4 into y minus 1 into 9y plus 15. That is 9y plus 15. That should be what? Greater than or equal to 0. Okay. This and this got cancelled. Expand this and you will get 4y square plus 4y plus 1. Okay. Minus of this is 9y square plus 15y minus 9y plus, I think it's plus 6y. Okay. 6y minus 15 greater than or equal to 0. Okay. And what is 4y square minus 9y square? That is minus 5y square minus 2y plus 16 greater than or equal to 0. That is 5y square plus 2y minus 16 less than or equal to 0. Okay. And to factorize this, I think it will be better if we go for the factorization method or quadratic equation method. That is minus 80 that is 16 and 5. Or we can go for quadratic equation method, that is y is equal to minus 2 plus or minus, that is 4 plus 4 into 80, 320, 324, that is 324 is 18 by what? 10, that is minus 20 by 10 is minus 2 and 16 by 10 is what? 8 by 5, that is 5x minus 8 into 5x minus 8 into x plus 2, that is x plus 2. Okay, that is less than or equal to 0. Okay, therefore, if you mark the points, it will be like minus 2 here and 8 by 5 here. So, the values will be from here to here. Okay, so the elements of y is from what? Element of closed interval minus 2 to 8 by 5. Okay, so the range of the given function will be what? That is y. That is y is equal to, we wrote it like that. And what is the parameter of y here? Minus closed interval minus 2 to what? 8 by 5. So, is it an onto function or into function? It's an into function because they are not using all the elements of the codomain. And what was the codomain here? Real numbers. Okay, and from the real numbers only this part is used. Therefore, it is not a 1 function. So, onto function, it is a which function? Into function. Okay, hope you got the idea here. So, what is the final result here? Neither 1 nor onto. Okay, so let's move to the next question. Yeah, interesting one. See, let this be the greatest integer, that is box T, less than or equal to T, and A be the set of all prime factors of 2, 3, 1, 0. Okay, and f defined from A to integer be the function f of x is equal to log of x square plus x cube by 5 to the base 2 and box of that. Okay, and the number of 1, functions from A to the range of f is, yeah. So, let's formulate this. There is a shortcut for doing this one. Okay, I will tell you. See, listen. Which are the prime factors of 2, 3, 1, 0? Let's formulate that. 2, 3, 1, 0. It's a special number actually. That is 2 is what? 2 and 5 will be the factors, right? That is 2 and 5 will be the factors since the last number is even and it is a multiple of 5. Okay, and is 3 a multiple? If you add it, you will get a number 6. Okay, therefore it is a multiple of 3. And 7. Is 7 a factor of this one? Yeah, 7 is a factor. And what about 11? Is 11 a factor of 2, 3, 1, 0? That is 11 times again 21, right? That is 22, 1, 1. Yes, 11 is a factor. That is, the factors are like 2, 3, 5, 7, 11. Okay, that is 2, 3, 1, 0 is a product of first 5 prime numbers. Okay, that is 2, 3, 5, 0 is equal to 2 into 3 into 5 into 7 into what? 11. That is a product of first 5 prime numbers. Okay. So, they have given another function like f of x is equal to log 2 into x square plus x cube by 5. Okay. Then the number of 1, functions from A to the range of f is. See, here we already got the answer because here we have A, right? That is A. A is what? 2, 3, 5, 7, 11. And here we have another set Z. Okay. Will be obtained after substituting the value here. Okay. So, if you substitute x is equal to 2, you will get some value. Let's take it as A. Substitute 3, you will get some value B, 5, 7 and 11. Okay. So, 5 elements here and 5 elements here as well. So, total how many elements will be, how many 1 functions will be there? 5 factorial, that is what? 120. See, but the problem here is, sometimes if you substitute this value, there is a possibility that if you substitute 2, okay, if you substitute 2, suppose we are getting the value k, and if you substitute 3 also, maybe you will get the same value k, okay, then for 2 and 3, they will have the same value. So, how many elements will be there? If that is the case, how many elements will be there? Less than 5 elements will be there. If that's the case, then how many 1 functions will be there? 0. 0 is not given in the option. I hope you're getting the idea here. Therefore, how many 1 functions will be there? 120 1 functions will be there. That is 5 factorial. See, after substituting and obtaining the codomain, that I will teach you after this. Okay, this was the shortcut. There is no need of finding the codomain here because of the option. Okay, so what is the correct answer here? 120. I will tell you how to obtain the values if you substitute 2, 3 and 5 from this. Okay, wait. What is f of x? Log of, that is f of x is equal to log base was 2, right? And I think we have x cube by x square plus x cube by 5, that is x square plus x cube by 5. There is a box here and there is a box here as well. Okay, so if you substitute 2, what will you get? That is log, that is 2, that is 2 square plus, see what is 2 cube by 5? 2 cube is what? 8, and 8 by 5 is what? 1 point something. What is box 1 point something? What is box 1 point something? Box itself, that is net value will be what? 5. Okay. So, what is the result of this? What is the box of this? It is easy actually. See, the answer is like, see, log 5. Log 5 lies between log 2 square, and that is 4, and log 2 cube to the base 2, right? That is log 5 to the base 2 lies between log 2 square to the base 2 and what? Log 2 cube to the base 2. What is log 2 square to the base 2? 2. What is log 2 cube to the base 2? 3. That is log 5 lies between 2 and 3. That is log 5 will be 2 point something. Log 5 to the base 2 will be 2 point something. What is box 2 point something? 2. That's all. That's how we find the value of when x is equal to 2. Let's go for another thing. X is equal to, the next value was 3, right? That is log base 2. That is 3 becomes 3 square plus 3 cube is 27. 27 by 5 is 5 point something. That is 5. That is 3 cube plus 5. That is 14, right? That is 14. Okay, so how will you find the value of log box 14 to the base 2? Easy actually. That is, this value lies between log 2 raised to 4 to the base 2. Okay, and log, okay, sorry, not that, that is log the 16 and 8, right? That is, yes, log 2 cube to the base 2 and log 2 raised to 4 to the base 2. Okay, that is where log 14 to the base 2 lies between, that is log between log 8 to the base 2 and log 16 to the base 2, right? That is, this the value is what? 3 and value is what? 4. So, basically log 14 to the base 2 lies between 3 and 4, that is it will be 3 point something. So, what is box 3 point something? 3. That is how you formulate the value of box of log x square plus box x cube by 3. Okay, and you will get 5 different values like this. So, 5 values in set A and 5 values in the corresponding codomain. That is 5 values in the domain and 5 values in the codomain. Therefore, how many 1 functions are possible? 5 factorial, that is 120. Okay, easy one. There is no need of doing this. Okay, I formulated this for you. Because maybe a part of this, how to formulate this, will be asked along with the other question. Okay, that's fine. Hope you got the idea here. Was a very easy question. And next one. Yeah, a function f defined from r minus set minus 2 to r and g is equal to r minus set minus 5 by 2 to r. Okay, so the domain of function f is what? This one. and domain of function g is what? This one. Okay, and codomain is real numbers, is defined by f of x is equal to 2x plus 3 divided by 2x plus 1, and g of x is equal to mod x plus 1 divided by 2x plus 5. Then you need to find the domain of the function f of g. So how are you going to find the domain of the function f of g? It's easy actually. So what is f of g? That is f of g of x. That is f of g of x. Okay, that is f of g of x is what? 2 into g of x plus 3 divided by 2 into g of x plus 1. So what is g of x? This value, right? That is, it will be 2 into 2 into mod x plus 1. There is one more thing which I need to mention after this. 2x plus 5, okay, plus 3 divided by 2 into mod x plus 1 divided by 2x plus 5, okay, plus 1. Okay, this is what f of g of x is. So what is the domain of g? That is r minus 5 by 2 is the domain of g. Okay, so that should be, this number can also be, that is minus 5 by 2 can also be not substituted here. Okay, we cannot use the number minus 5 by 2 because g is here. G cannot have which value? Minus 5 by 2. So already we can exclude this option and this option. That is, the domain of this function should not have what? Minus 5 by 2. Therefore, the final answer will be either this one or what? This one. That we can formulate from here. Okay. After cross multiplication, it will be 2 times mod x. Okay. Plus 6 times what? X. 2 and 15. That is 17, right? That is plus, okay, 17 divided by, this will get cancelled here and here. Don't bother that. That is 2 times, again, 2 times box x plus 2 times x. That is plus 2 times x. 2 plus 5, that is what? 7. Okay, that is what f of g is. Okay, this is what f of g is. Okay, then to find the domain, we need to go for opening the modulus. Okay, okay, two cases were, the case 1. Case 1 is what? Mod x greater than or equal to 0. Therefore, f of g will be, this is 2x plus 6x, that is what? 8x plus 7 divided by 4x plus 7. Okay. So here x cannot be equal to what? Minus 7 by 4. X cannot be equal to minus 7 by 4. You are getting the idea or not? X cannot be equal to minus 7 by 4. So the next one. Okay. That is f of g. Okay. That is equal to, this is x less than 0. That is x less than 0. Okay. That is, it will be okay, this will be minus 2x. Minus 2x plus 6x is what? 4x. That is, it is 4x plus, that is, this will be 17. Okay, that is 17 divided by, if it is less than 0, this becomes minus 2x. That is minus 2x and 2x got cancelled. This becomes what? By 7. That is f of g is equal to what? 4x plus 17 by 7. We can substitute any value here. Okay. So compare to the two values, that is here we have x is equal to not minus 7 by 4. But that is not possible. Why? Because x can never be minus 7 by 4. We have already put a condition here like x is greater than or equal to 0. Okay. So combining these two, what is the result here? This is not applicable because here we have already formulated like x is greater than or equal to 0. But here we have obtained what? X is equal to minus 1 by 4. Okay. So even though we cannot substitute minus 1 by 4 here, the another condition is like x is greater than or equal to 0. Okay. Both the conditions is not satisfying. Okay. Therefore, what is the condition here? R is equal to minus of what? Minus 5 by 2. This is the final cut answer. Okay. So what is the domain of f of g? Minus of minus 5 by 2. So see, sometimes see, if it is like 4x minus 7. If it was like 4x minus 7, the value will be what? X not equal to 7 by 4. Therefore, we cannot include 7 by 4 and minus 5 by 2. In this case, you should do the problem like that. Okay. I hope you got the idea here. Okay. So, our next question. Okay. So, it's not the, okay, part of ending. fg defined from real numbers to real numbers, defined as f of x is equal to mod x minus 1. Okay. And g of x is equal to e raised to x greater than or equal to 0 and x plus 1, x less than or equal to 0. Then the function f of g of x is, the options are neither 1 1 nor on 2, 1 1 but not on 2, 1 1 but not 1 1. That is, you need to find whether the function is 1 1 or many 1 and on 2 or into. How are you going to formulate that? Easy actually. Let's formulate this one first. So what is f of x? F of x is equal to, it will be x minus 1, sorry, it will be x minus 1 when x is greater than or equal to 1, and it will be 1 minus x when x is less than 1. Okay. Okay, next one. So what is g of x? E raised to x when x greater than or equal to 0 and x plus 1 when x is less than or equal to 0. Then the function f of g of x is. So let's substitute it first. What is f of g of x? It's a slightly typical one, and the most of the students will call it like a slightly hard-nut question like that, but it's a very easy question once you got the idea. Okay, so let's find f of g of x first. So how will you find f of g of x? Put g of x everywhere, including here and here as well. So this becomes g of x minus 1, 1 minus g of x. Okay, where g of x greater than or equal to 1 here and g of x less than 1. Okay, so this is what it looks like after composition. So I think it will be better if you draw the graph of g of x. Okay, I think we can formulate it on the next slide. That will be better. That is f of g of x. Again, what is f of g of x? There is one more thing to describe and detail. I think it will be better if you do it on one slide. That's why, that is g of x is equal to, that is g of, sorry, that was next question. That is g of x minus 1. That is g of x minus 1 and 1 minus g of x if g of x greater than or equal to 1 and g of x less than 0. So what was g of x? G of x is equal to e raised to x, right? E raised to x and x plus 1, e raised to x and x plus 1, x greater than or equal to 0 and x less than or equal to 0. Okay, so to crack this question, let's draw the graph of g of x. Okay, therefore the graph of g of x will be, in most cases it will be easy. Okay, g of x will be e raised to x when x greater than or equal to 0, right? Therefore it will be like this. Okay, e raised to x when x greater than or equal to 0. This point will be 0, 1. And for x less than or equal to 0, it will be x plus 1, right? Here the point is minus 1 comma 0. So from here to here, it will be like this. Okay, so this is what the graph of g of x looks like. Okay, now comes the important part of this question. That is, f of g of x is equal to, where is g of x greater than or equal to 1? From this graph, kindly plot where is g of x greater than or equal to 1. Where x is greater than or equal to 0. See, x is greater than or equal to 0, g of x has this point, right? This is point 0, 1. This is where from this point g of x hits greater than or equal to 1 values. Okay, so for which value of x does g of x greater than or equal to 1? That value we need to assign here, that is x greater than or equal to 0. Okay, if x is, okay, and for which value g of x is less than 0? For which value g of x is less than 0? Sorry, here g of x is less than 1. Okay, my mistake, it is less than 1. For which value is g of x less than 1? Values from which when x is less than or equal to 0. So when x is less than or equal to 0, see this is 0, 1, its values start dipping. Okay, we have formulated this. Next one. For x greater than or equal to 0, what is the value of g of x? E raised to x. That value we need to assign here. That is e raised to x minus 1. Okay, for g of x, we need to assign the corresponding value. And for x less than or equal to 0, what is the value of g of x? That is x plus 1. That is 1 minus of x plus 1. Its value will be reduced to what? Minus x. So this is what f of g of x looks like. E raised to x minus 1 and minus x. So let's plot this. E raised to x minus 1 will be, e raised to x will be like this. E raised to x minus 1 will be 1 units downwards, therefore it will be like this. And what is minus x? When x less than 0, see the graph of y is equal to minus x will be like this. But in this region, x is greater than or equal to 0. Therefore, we need to include this region. Okay, therefore, this and this. Which function is this? See the function, I think g of f is defined from R to R, right? Yes, it is defined from R to R. Therefore, g of f it is defined from R to R. So, what can you obtain from here? Is this a 1, 1 function? How will you formulate from the graph that it is either 1, 1 or many 1? For that, we need to go through HLT test. HLT test means horizontal line test. Okay. So, through this graph, just draw a horizontal line. If the line cuts the graph at more than 1 point, then the function is what? Many 1. If the line cuts the graph at only 1 point, then the function is what? 1, 1. Here it cuts at more than 1 point, then for the function is what? Many 1. So, is it onto or into? See, the codomain is what? Real numbers. If you look at the graph, none of the negative real numbers are used. Okay, they are left unused. Therefore, the function is what? Into. Therefore, the function is neither 1, 1 nor what? Onto. That is the final cut answer. Hope you got the idea here. Okay, next one. Similar question is back again. Okay, next one. Yeah. F is defined from real numbers to real numbers. G is defined from real numbers to real numbers. Both the functions are given. F of x and g of x are given. These types of functions are called piecewise functions. Okay. When a function has multiple characters in its domain, those types of functions are called piecewise functions. Okay. And we need to find g of f. We can directly write that here. What is g of f? That is g of f of x. What is g of f of x? That is f of x here, that is f of x when f of x greater than or equal to 0 and e raised to f of x when f of x is what? Less than 0. Okay, what is our next step? We need to find the values for f of x hits greater than or equal to values, 0 values, and f of x less than 0. Okay, for that I think it will be better if you start with the graph of f of x. So what is the graph of f of x? How will you formulate the graph of f of x? Okay, let's start from here like this. See, for x greater than 0, the graph of f of x is what? Log x. So it will be like this. Okay, this point you all know that point is 1, 0. This is 0, 0. Between 0 and 1 open interval, value of log is negative. Okay. If it is a value greater than 1 here. And e raised to minus x. What is the figure of e raised to minus x? This will be like this. Okay, so the graph is like this. Okay, so let's formulate. So, which are the values where f of x hits greater than or equal to 0 values? That is, f of x is non-negative in which region? See, from the figure we can easily conclude that f of x is greater than 0 in this region and this region. That is, x when x hits greater than or equal to 1 or x hits less than or equal to 0. Okay, so we can write those values here. F of x is greater than or equal to 0 when x is less than or equal to 0 or x is what? Greater than or equal to 1. In both the cases, f of x is what? Greater than or equal to 0. Hope you are getting the idea here. And where is f of x less than 0? That is between this and this. That is between 0 and 1. That is 0 less than x less than 1. Okay, that's over. The problem is almost done. Then we can substitute the values here. That is g of f of x is equal to, okay, when x is less than or equal to 0, it is f of x, right? X is less than or equal to 0. What is the value of f of x? X is less than or equal to 0. The value of f of x is what? E raised to x. So here we need to write what? E raised to x. Sorry. Here, from here, right? When x is less than or equal to 0, the value of f of x is what? E raised to minus x. That is x less than or equal to 0. So, my mistake. And for x greater than or equal to 1, for x greater than or equal to 1, we need to obtain this values. That is log x to the base c. F of x is what? Log x to the base c. Therefore, log x to the base c when x greater than or equal to 1. Okay. Next one. See, between 0 and 1, what is the value of f of, what is the value? Between 0 and 1 means we need to use this one, that is e raised to minus x, that is e raised to f of x is here. Okay, so between 0 and 1, sorry, between 0 and 1 f of x using log x. Okay, therefore it will be e raised to log x. I hope you got the idea here. Between 0 and 1, the value of f of x is what? Log x. Therefore, it will be e raised to log x here. If you formulate it, it will be like, that is g of f of x will be, that is between 0 and 1. Okay, sorry, between 0 and 1. Okay, it will be like x less than or equal to 0. In the respective order, I am writing this e raised to minus x. Between 0 and 1, it will be e raised to log x is what? X. And x greater than or equal to 1, it will be what? Log x. Okay, we need to plot this, only then you will get an idea about whether it's 1, 1 or many 1. Okay, so let's start. Okay, the graph will be like, for x greater than or equal to 1, it is log x. So, if it is 1 here, it will be like this. Okay, greater than or equal to log x. X greater than or equal to 1. Between 0 and 1, it is x. Therefore, it will be, I can draw it with another ink, that is from here to here. Okay, this is 1. Okay, that is x. So, last thing, e raised to minus x when x less than or equal to 0. Okay, e raised to minus x will be like this when x less than or equal to 0. So, the graph will be like this. So, we know that g of f, right? We know that g of f is defined from real numbers to real numbers. So, which function is this? 1, 1 or many 1? If you draw a horizontal line, it will easily fail. Therefore, it is which function? Many 1. And is it onto or into? See, the codomain is real numbers. Are they using all the real numbers? Absolutely no, not. Therefore, this function is what? Into. Therefore, it is neither 1, 1 nor what? Onto. Okay. It is like this. Okay. See, the questions based on finding the domain, also to identify whether the function is 1, 1 or many 1, for composition of functions are asking frequently. Okay, and the numbers are keeping increasing. Okay, as each year. So, be careful with this one. Okay, the steps are very easy. First, you compose it directly. Okay, substitute the function f of x everywhere, then draw the graph of f of x, and then plot according to the corresponding inequality. Then find x from the graph where f of x is greater than or equal to 0 at 2 points and f of x less than or equal to less than 0 at 1 region. Here 2 regions and here 1 region, and then substitute the value from here to this. Okay, that's it. Okay, that's all for the question. And next one. Yeah, one more question. See, f of x is equal to 2 plus 2x and 1 minus x by 3 minus 1 to 0 and 0 to 3. And g of x is given minus x and x between minus 3 to 0 and 0 to 1. Okay, then you need to find the range of what? F of g of x. Let's compose it first. F of g of x. So, f of g of x. Okay, so it will be 2 plus 2 into g of x and 1 minus g of x by 3. Okay, hope you got the idea. And minus 1 less than or equal to g of x less than 0 and 0 less than or equal to g of x less than or equal to 3. Okay, it's a slightly typical question. So, let's formulate it. Let's draw the graph of g of x. I think it's easy also. Okay, so minus 3, this is 0 and this is 1, up to 1, right? Okay, so minus 3 to 3, the graph of g of x is what? Minus x, though it will be like this. This point will be 3. Okay, I am not marking the corresponding minus 3, 0, 0, 3, you know that, right? Okay, and from 0 to 1, what is the value of g of x? That is like this. This is 1. Okay, slight modification here. Okay, this is 1. Okay, that's all. This is the graph of g of x. Okay, so what about this one? How will you formulate this one? When is g of x lies between minus 1 and 0? What are the corresponding values of x? Could you tell me? G of x lies between minus 1 and open 0. It is not taking 0 also. There is no value for x such that g of x is negative according to the given function. Why? Because if you, okay. Okay, so the graph of g of x is like this. It is starting from 0 to 3. Okay, so the range of g of x is what? Basically from closed interval 0 to 3 only. So it is not hitting any negative values. Therefore, this we do not have to formulate. But this we have to formulate. Okay, so when is g of x lies between 0 less than or equal to g of x less than or equal to 3? That is, when is the value of g of x shuttling between closed interval 0 to closed interval 3? This one or this one? When? The value of g of x is shuttling between closed interval 0 to 3 only when x becomes what? 0 to minus 3. That is minus 3 to 0. That is, it is happening only when x element of what? Only when minus 3 less than or equal to x less than or equal to 0. Here you can easily verify that in here the value of g of x lies lying between 0 and 3. Therefore, it is like this. Therefore, f of g of x will be equal to 1 minus. So, what is the value of g of x? G of x when x is between minus 3 and 0? Minus x. Therefore, it will be a minus here and a minus here as well becomes what? Positive. That is when minus 3 less than or equal to x less than or equal to what? 0. Okay. So, this is the value of f of g of x. Okay. I told you it was a slightly typical question because we don't have to formulate this one. Okay. Then we need to find the range. It's very easy. Substitute the minimum value here. You will get what? That is 1 plus minus 3 by 3. That is 1 minus 1. That is 0. Okay. And substitute 0 here. You will get what? 1. Okay. If you have any doubt, it's an increasing function. That is f dash is what? Positive. Therefore, it is an increasing function. That is f dash of this function. If you differentiate this function, that is which function? That is a positive. You get a constant value. That is a constant positive value. That means this function is increasing. Okay. That means this will have the minimum value and this will have the maximum value. So, the interval is lying from closed interval 0 to 1. That is option 3. That's all. Done and understood. Next one. Okay. The number of distinct real roots of the equation mod x into mod x plus 2 minus 5 into mod x plus 1 minus 1 is. How are you going to do this one? I think it's pretty easy actually, but the steps are more. Okay. First, we need to identify the region where each of them is separately equal to 0. Where is mod x 0? When x is equal to 0. And this is minus 1 when this becomes 0 and this is minus 2. Okay. So, let's formulate. So, let's consider the case where x is greater than or equal to 0. And is x is greater than or equal to 0. When x is greater than or equal to 0, this becomes, let's write it here. Okay. X is greater than or equal to 0. This will be positive. This will be positive. This will be positive. Therefore, it will be x into x plus 2 minus 5 into x plus 1 minus 1, which is equal to 0. When x is greater than or equal to 0. Okay. Sorry. Equal to 0 when x is greater than or equal to 0. Okay. So, let us operate it. That is x square. Okay. That is x square. This is 2x and minus 5x. Minus 3x. This is minus 5 minus 1. Minus 6 is equal to 0. Wait. Next is this one and this one. That is minus 1 less than x less than or equal to x less than 0. That is in between here and here. This becomes negative. This becomes positive. And what about this one? That is also what? Positive. Minus 1.0. Yeah, that's positive. Therefore, minus of x into x plus 2 minus 5 into x plus 1 minus 1 is equal to 0. So, if you simplify it, you will get minus x square, right? Minus x square minus 2x minus 5x. That is minus 7x minus 5 minus 1. That is minus 6 is equal to 0. Hope you are getting the idea here. Next is from minus 1 to minus 2. That is minus 2 less than or equal to x less than minus 1. Okay, in here this will be negative. This will be positive, right? Minus 1. Yeah, positive. This will be negative. Therefore, minus x into x plus 2. As this is negative, there will be a plus sign here. Plus 5 into x plus 1 minus 1 is equal to 0. So, after operating it, you will get minus x square minus 2x plus 5x, that is plus 3x. Okay. And 5 minus 1, that is 4. That is 4 is equal to 0. Last one, x less than or equal to minus 2. This and this will be positive. Therefore, it will be x into x plus 2, that is x square, that is x into x plus 2. This will be negative, makes it positive, that is plus 5 into x plus 1 minus 1 is equal to 0. Okay, that is x square. I told you the calculation bit more. X square plus 7x plus 7x plus 4 is equal to 0. So basically, how many quadratic equations? 4, right? 1, 2, 3, 4. 4 quadratic equations. So let's solve the first one. X square minus 3x plus minus 6 is equal to 0. That is, this one I am solving. 3 plus or minus root of b square, that is 9. 9 plus 24, that is 33. 33 by what? 2. Okay. So 3 plus or minus root 33 by 2. In here we are considering x greater than or equal to 0 only. So we need to focus on one part only, that is 3 plus root 33 by 2. 3 minus root 33 by 2 is a negative value. Okay. Therefore, we need to focus on this only, 3 plus root 3 by 2. That is for x greater than or equal to 0. So how many values here? One value. C, one solution. C, normally we will have two solutions, but at first the condition was like this, x greater than or equal to 0. So for that, how many values? One value according to the given condition. So next one. This I think x square plus 7x plus 6. We can write it like this. X square plus 7x plus 6 is equal to 0. If you formulate it, the values will be like x plus 1 into x plus 6 is equal to 0. That values will be like minus 1 and minus 6. So minus 1 lies in here. Therefore, only one solution. Minus 6 we cannot take because it lies between minus 1 and 0. Therefore, how many solutions here? 1. Next one. This I think we can formulate it like x square minus 3x minus 4, right? X square minus 3x minus 4 is equal to 0. How will you formulate this? That is x plus, x minus 4 into x plus 1 is equal to 0. That is minus 1 and 4. Okay, 4 we cannot take. Minus 1 can we take? No, minus 1 is not included. Therefore, according to the given condition, see, the equation has two solutions, but according to the given condition, no solution. Okay, that is no solution. 0 solutions here. Okay, no solutions. X square plus 7x plus 4. That is minus 7 plus or minus root b square. 49 minus 16. What is 49 minus 16? 33. Again 33, right? 33 by 2. That is minus 7 plus 33 by 2. The value of 33 is what? It will be 5 point something. That is, I think the page is full. Minus 7 plus or minus 33 by 2. Minus 7 plus or minus 5 point something by 2. Two values you will get. Minus 7 minus 5 point something minus 12 point something by 2 is what? Minus 6 point something, and minus 7 plus 5 point something, that is minus 2 point something by 2 is what? Minus 1 point something. This we cannot take. This we can take, right? Since it is x is what? Less than or equal to minus 2. Okay. So, how many solutions? According to the given condition, one solution. So, total 1 plus 1 plus 1, number of real roots is what? 3. Okay. Hope you got the idea here. It's also a question which is kept asked repeatedly. Okay. So, our next one. Okay. Our last question from functions. Okay. Easy one. F of x is equal to 2 raised to x minus x square, x element of R. If m and n are respectively the number of points at which the curves y is equal to f of x and curve y is equal to f dash of x intersects the x-axis, then you need to find the value of m plus n. Okay. So, it will be like y is equal to f of x, that is, this is y, right? That is y is equal to 2 raised to x minus x square. See, if the curve intersects the x-axis, then what is the corresponding value of y there? Y is equal to 0, right? Okay, if it intersects the x-axis, the value of y is what? 0. If y is equal to 0, then we can formulate like 2 raised to x is equal to what? X square. So, let us formulate this. That is, x square, the graph will be like this, right? Okay. And 2 raised to x, the graph will be like this. Okay. Is there any problem? Let's formulate this out. Okay. So up to here, I think the graph will be correct. Okay. From here to here, we need to check it out. Okay. 2 raised to x is equal to x square. Could you tell me any two values, any one value or two values for which this will be same? What if x is equal to 2? That is 2 square is equal to 2 square, that is what, 4. Is there any other value for x? Two methods we can use here, either differentiation or basic conventional method, trial and error method. I am going for the trial and error method. Okay. Is there any other value? X is equal to what? 4. I think that is 2 raised to 4 is equal to 16. That is also equal to 4 square. So, in the first quadrant, they are meeting for 2 points. So, let's change the graph. Okay. Let's draw it again. Okay. Let's draw this again. So, x square will be like this. Okay. So, the graph will be like this, and I think they will again meet. Here we have 2 and here we have 4. So, how many points is it intersecting? 3 points. Okay. So, if you differentiate it, you will get what? Y dash is equal to 2 raised to x log 2 minus what? 2x. Okay. So, 2 raised to x log 2 and 2x, that is if it intersect the x axis, therefore, this should be 0, that is 2 raised to x log 2 will be equal to what? 2x. So, if you draw the graph, it will be somewhat like this, that is y is equal to 2x will be like this and 2 raised to x log 2. Okay, it will be like this. Okay. So, how many points is it intersecting? 2 points and 2 plus 3. So, how many points are there? 5 points. Therefore, what is the value of m plus n? 5. Okay. See, I have gone for trial and error method in this case, okay, for solving this one. It was an easy question and doable question and a time saving question also. Okay. So, that's it. That's it for functions. We have discussed so many questions from 2024 and 2025. Not so many, all the questions. Okay. And stay tuned till the next video. Okay. And as again, just go for all of these questions one more time. Okay. And try to do the question by yourself. Okay. Basically, the questions with finding the domain, identify the functions for composition of functions like that. Okay. It will help you a lot for the upcoming examination. Okay. And thank you for listening till the end of the video and take care. Okay. See you at the next video. Okay.